Okay, so quick review. 3x times 3x is 9x squared. 3x times 5 is plus 15x. Negative 5 times 3 is minus 15x. And negative 5 times 5 is negative 25. What happens when I combine like terms here? 15x and negative 15x are gone, and I'm just left with x, if I could speak, 9x squared minus 25. What's special about that? The x's cancel out. How many terms do we have here? Two. So this is special. It's something that we haven't necessarily looked at. We've looked at a way of doing this, but today we're going to look at a quick shortcut that will save you some time. Okay. So remember, factoring is like undoing distribution or undoing multiplication. So let's look at a couple factoring problems. So I want you to do 2 and 3. Try these 2 and 3, please. So remember, I have shown you how to do two terms by figuring out what's missing. You guys remember that? What's missing in both of these problems? The b. So what does the b have to be? 0. So you plug a 0 in for b, and then you can do the AC method like normal. So I'll give you a minute or so to do 2 and 3 together with your groups. Go ahead. All right, so the way we have learned to deal with two terms is to stick something in the middle. So I'm going to put my plus 0x in there because adding 0 in the middle won't change anything. Okay, now I can go ahead and do the AC method like normal. So I do a, which is x squared, times c, which is negative 9, so negative 9x squared. And then I want factors of that add to 0. So since it's a negative, I know it's going to be one positive, one negative. What two terms would add to 0 that multiply to 9? Negative 3 and positive 3, right? So I have negative 3x and positive 3x. So now I break my middle term apart. So x squared stays. That 0x breaks into minus 3x plus 3x. And I bring down my minus 9. Oh, wait. No, we don't have an equal 0 here. Sorry. Adding extra stuff on there. Okay, now that I have 4 terms, I can group like normal. So the only thing that's different about these is just plugging a 0x in the middle. And to be totally honest, you don't even need to learn what I teach you today if you can do this. If you don't remember a word I say today and you know how to do this, you're fine. I'm just going to teach you a quicker way of doing it when there are two problems, or two terms, excuse me. All right, so now I group the first two together and I bring out an x, divide both of those, divide the GCF out of both of those, and I'm left with x minus 3. And then out of the last two terms, I can bring out a plus 3, and I'm left with x minus 3. So the x minus 3 comes out, and the x plus 3 is left over. Yes, ma'am.
I was able to solve that without doing like all the work. Is like there was a question on a test like that, I didn't do the work.
You honestly probably did what I'm getting ready to teach you. What did you do?
There's 2x, so I just split that up into 2, and I just divided. I mean, I got what would make negative 9. So
Yeah.
X minus 3 and x plus 3.
Yeah. You just did what I'm going to teach you today, basically, in a nutshell. Okay. What? Yeah, in enrichment. All right, so second piece here. So I have 4x squared plus 0x minus 49. So this one's a little tougher because my numbers are a little bit bigger. Okay. So what is 4 times 49? 196. Okay. So it's negative 196x squared. And then I need factors that add to 0. So this is where doing the AC method this way kind of gets a little tricky. So what two numbers, and obviously they would have to be the same if they're going to add to 0. Do you guys know the quick and easy way of figuring out what two numbers that are exactly the same multiply to give you 96 or 196?
Ooh, square root and then make one of them negative.
Yeah, okay, so I heard two things here and I want to clear it up. Divide by 2 is a no-no. That would just cut it in half. That would give you what two numbers add to give you 196 that are the same. A square root is the opposite of a square, so it would take 196 backward and say, okay, what is it? What's the square root of 196? 14? So it would be 14 times 14 would give you 196. Okay? And since it's negative here, remember we need positive and negative, so minus 14x and positive 14x. Woo! Must be. Sorry for the people on the video notes that just heard me sneeze. All right. Hopefully I didn't bust your speakers. So we have 4x squared minus 14x plus 14x minus 49. All right, so now I'm doing my GCF. So out of the first two, I can bring out a 2 and an x. So 4x squared divided by 2x is 2x. Negative 14x divided by 2x is minus 7. And then out of the last two, it looks like I can divide a 7 out of 14 and 49. So plus 7. And I'm left with 2x minus 7. So the 2x minus 7 is left in common. And the 2x plus 7 is left over. All right, so here's what I want you to do. So the question right under that says, do you see a pattern? I want you to take a quick 30 seconds, and I want you guys to talk about any patterns you see between our problems and our answers. Okay, on 2 and 3, go ahead.
What was the question, Mr. Craw? Mr. Craw, what was your question?
What patterns do you see between the problems and the answers? Because we're leading to trying to figure out, can we come up with some rule?
You have to find the cube. No, I said 0. You just have to get 0.
It's like right on the left.
Okay. Oh, I left it recording that whole time. What kinds of patterns did you guys come up with? Yeah, Joe.
Like the first part of the answer is like different than the second part. Like the number in the first one's like the opposite of the number in the second one. Like one's negative.
Oh, so you're talking about the signs in the middle.
Yeah.
One's plus, one's minus.
Yeah.
Okay. What other patterns did you see? Maybe going from the problem to the answer? Angel?
You could just basically divide, but you could use the two coefficients and the two variables to just get the problem.
Okay, so you said you can use the two variables and the numbers and all that kind of stuff to get the problem. How would we go from the problem to the answers?
Just divide.
Are we dividing? Yeah, Colin?
Well, in both problems, the number outside the parentheses, you eliminated it?
Not quite. Eliza?
You could just divide the numbers and the square root of them.
Wait, you said two different things. Divide them or square root them? Square root them, right? Because a square root will give me the two things that I would have to multiply together to get the answer. To get the problem. All right, so let's think about this. And really all this is just thinking about the simplicity of it. So let's look at a rule here. So it says, write a rule to factor a binomial of the form a squared minus b squared. Okay? So there are a couple things that are important about this. This is called a difference of squares. What does a difference mean? Subtraction. So it always has to be a subtraction problem. And squares refers to perfect squares. So you have to be able to take the square root of of both terms, and it has to be subtraction in order to do this, okay? So if we think about this, I'm going to have two sets of parentheses. And let's think about what goes in those parentheses. So if you remember right, my first term times the first term always gives me that whatever squared outside. So what would I multiply together to give me a squared? What two things would I have to multiply together to give me a squared? A and a. We figure that out by taking the square root of a squared, which is a. So the square root of a squared is a. So I'd have to multiply a times a. What would I have to multiply? So remember, these back two terms are going to give me the last term. So what would I have to multiply together to get b squared? B and b. And how, so we figured out, or we got this, and we got this. How do I get the middle terms to cancel out? What kinds of things cancel each other out? Opposites, right? Positives and negatives. So if I multiply the outside pieces and get AB, multiply the inside pieces and get AB, I need them to be opposites. How could we make them be opposites? A positive and a negative. So I'm going to do plus and minus. So every difference of squares is always plus and minus, and all I'm really doing is just taking the square root of the pieces. I'm trying to figure out what two things would multiply to give me those two pieces. Something I want you to be aware of. Always check for a GCF first. Just like all the other problems that we do, always check for a GCF first. Okay? So let's look at number one together really quick. We're just going to do a couple of these together, and then I'm going to let you guys go. So number one, actually, you know what? I want you guys to do them. Yeah, you're okay. So I want you to do all five of the try these. So there's 3 try these and then 2 solve problems. Do all 5. I'll give you like 5 minutes. These don't take that long, okay? So 3 factoring problems and 2 solving problems. Go ahead. Okay. I know some of you aren't quite done, but that's okay. You can just finish them as we're going through them here. So I always need to do what first? Try GCF. Is there anything that goes into 9 and 100?
No.
No. Okay. So now I'm ready for difference of squares because there are 2 terms. Okay. So I go ahead and make my 2 sets of parentheses. What 2 things would I have to multiply together to get 9r squared?
3R.
3r and 3r. And I could figure that out by a square root if I needed to. So 3r and 3r. What would be the last 2 pieces that I have to multiply together to get negative 100s squared?
Negative 10s and 10.
Yeah, positive and negative 10s. So plus 10s and minus 10s. Would your middle term disappear here? Always check that. 3r times negative 10s would be negative 30 and positive 30. So my RS's would cancel out in the middle and I'm good. Okay? All right, let's check 2. I should always try a GCF. Is 36 and 16 both divisible by something? Yep. So if you have 6x plus 4 and 6x minus 4, you are wrong. Sorry. Okay. So I can divide both of those by 4. So I go ahead and do my GCF, just like any other problem. And I'm left with 9x squared minus 4. Okay, now I'm just kind of ignoring this 4 outside, and I still have 2 terms inside, so try difference of squares. So the 4 is going to hang out front, and then in my 2 sets of parentheses, what would I have to multiply together to get 9x squared? 3x and 3x. What would I have to multiply together to get negative 4? Positive 2 and negative 2. And I'm done. Yeah, the 4 just stays out front as a GCF, as the original GCF. Okay, any questions there? I know that one was a little different because we had a GCF. Okay, let's look at 3. So I make my 2 sets of parentheses. What would I have to multiply together to get x squared? X and X. What would I have to multiply together to get positive 25?
5 and 5.
5 and 5. So plus 5 and plus 5. Let me ask you a question. We got the first, x squared. We got the last, 25x. What about outside and inside? Will they cancel here? What's x times 5?
X times 5x.
And 5 times x is another 5x. Does that cancel out? No. Is this a difference of squares? Why not? What does difference mean? Subtraction. Okay? So you have to start recognizing that. If I see two terms and I see a plus sign in the middle, it is prime. It is not factorable. So get rid of all this. And it is prime. Because of that right there.
So if your problem,
If it's two terms and it's a plus sign in the middle, it's not factorable.
has to be minus.
Yep. That's why it's a difference of squares. That's the only way you can get that middle term to cancel out is if the last one's negative, so that I can get that plus and minus in there. Another example, if I had 3x squared minus 9. No, that's a bad example. 3x squared minus 16. Can you figure out two things that are the same that multiply to 3x squared?
No.
That are whole numbers?
No.
Not really. So this is, again, not factorable. Okay? All right. So I can get rid of this. I just wanted to, oops, got rid of too much prime. Okay, so I just wanted to show you that. So be on the lookout for that. All right, now solving. Remember, I do the same thing to factor. I just have a couple of steps to solve at the end. So does anything divide into 36 and 49? It does? I don't think anything does. No, nothing does. Okay. All right. So I set my two parentheses out here. What could I multiply together to get 36x squared? 6x and 6x. And what could I do to get negative 49? Positive 7 and negative 7. So I factored. Now I can go ahead and solve. So in order, again, for this whole thing to be 0, either this could be 0, this could be 0. So 6x plus 7 could be 0, or 6x minus 7 could be 0. Subtract 7, divide by 6. You get negative 7/6. And positive 7/6. Okay, one more here. Number 2. Oh, sorry, yes.
Why did you divide by 6 on those?
Just regular two-step equations, right? In order to get rid of a plus 7, I minus 7 to both sides. In order to get rid of 6x, that's like 6 times x, so I would divide both sides by 6. Just goes back to our solving equation steps from last semester. Okay? All right, then here on number 2, is there a GCF?
Yeah.
Yes, they are both divisible by 4, or I think, right? Is it 144 divisible by 4? Yeah. And m. So my GCF here is going to be 4m. So 4m to the third divided by 4m is just m squared. What's 144 divided by 4? 36. So minus 36 and the m's cancel. Okay. Do you still have a difference of squares inside the parentheses? Yeah, it's a subtraction sign, and I can take the square root of both. So 4m hangs out front. What can I multiply together to give me m squared? M and m. Get it? Like the candy? Anyways. What multiplies together to give you negative 36? Plus 6 and negative 6. And now I can solve. How many answers am I going to have here? 3. This 4m out here gives me an answer. The m plus 6 gives me an answer. And the m minus 6 gives me an answer. So divide by 4 on both sides. 0 divided by 4 is still 0. So m equals 0. Subtract 6 from both sides. M equals negative 6. And add 6 to both sides. m equals positive 6. So there are my 3 answers. Okay, can I get a comfort level on difference of squares? How to factor with 2 terms. Good, we'll keep practicing. Practice makes perfect. Okay, the rest of the time is yours.